Have you ever heard about the chemical element, Californium? A fascinating element, Californium was first introduced to the world in the mid-20th century. In 1950, scientists Stanley Thompson, Kenneth Street Jr., Albert Ghiorso and Glenn Seaborg discovered this unique element at the University of California Radiation Laboratory. A proud member of the actinide series, Californium holds the 98th position on the periodic table. Now you might ask, what sets Californium apart? It's all about its radioactive nature. That's right, Californium is a radioactive metal, but don't let that scare you off. This characteristic is what makes Californium so intriguing. It's not just another run-of-the-mill element. Its radioactivity opens up a world of possibilities. Now that we've dipped our toes into the Californium waters, you might be wondering, what makes Californium so unique, and what are its uses? Stick around to find out. Californium is not just another element, it has some very interesting properties. Let's start with the basics. Californium is a silver-colored actinide metal, and like other actinides, it's heavy. Its density is around 15 times that of water. This metal has a relatively low melting point for a metal, around 900 degrees Celsius, and its boiling point is a scorching 1,700 degrees Celsius. But Californium's most intriguing property is its radioactivity. It's one of the most radioactive elements that we know of. Californium is so radioactive, in fact, that it emits neutrons. Neutrons are subatomic particles that, along with protons, make up the nucleus of an atom. These emissions make Californium extremely dangerous to handle without proper protective measures. Now we've learned that Californium is radioactive, but what does that mean exactly? Let's delve deeper. You may have heard the term half-life in relation to radioactive elements, but what does it mean? Well, the concept of half-life is actually quite simple. Imagine you've got a handful of radioactive atoms. The half-life is the time it takes for half of those atoms to decay or transform. It's like a ticking clock, but instead of seconds and minutes, we're measuring in atomic transformations. And this clock ticks differently for each radioactive element. Let's take Californium-252 as an example. This is an isotope of Californium, and it has a half-life of about 2.645 years. This means that if you started with a certain quantity of Californium-252, after around 2.5 years, half of it would have decayed into other elements. This ticking atomic clock is what makes radioactive elements so fascinating and, at times, perplexing. But wait, what's an isotope? Time to demystify that term. The term isotope might sound complicated, but it's actually quite simple. When we talk about isotopes, we're referring to variants of a particular chemical element that differ in neutron number. Let's break it down. Every element on the periodic table has a specific number of protons. This number is what defines an element. But here's an interesting fact. Atoms of the same element can have different numbers of neutrons. These different versions of the same element are what we call isotopes. And guess what? Californium is no exception. It has 20 known isotopes, each with its own unique set of properties. So the next time you hear the term isotope, remember that it's just a fancy way of saying a version of an element with a different number of neutrons. It's as simple as that. Now that we understand isotopes, let's explore how we use Californium in our daily lives. Despite its radioactivity, Californium has some incredibly beneficial uses. For instance, Californium-252, a specific isotope of this element, plays a crucial role in the medical world. It's used in cancer treatment, specifically neutron radiation therapy, where it helps to destroy cancerous cells without causing extensive damage to healthy cells around the tumor. Californium also shines in the field of metallurgy. It's employed in portable metal detectors, helping to identify gold and silver ores for mining operations. Another fascinating use of this element is in oil exploration. Californium-252 can help detect the presence of oil and gas in underground formations by neutron logging, a process that measures the concentration of neutrons in a material. So, Californium is not just a radioactive element sitting on the periodic table. It's a versatile tool that aids in everything from medical treatments to resource exploration, proving that even the most dangerous things can have beneficial uses. So Californium is quite a useful element, but it comes with a hefty price tag. Californium-252, one of the most commonly used isotopes of californium, is one of the most expensive substances by weight. Now, you might be wondering why that is. The answer lies in the combination of its production difficulty and its unique usefulness. Producing Californium-252 is no small feat. It involves bombarding curium with neutrons in a nuclear reactor, followed by a series of complex chemical processes. This, coupled with the fact that it's produced in minute quantities, drives up its cost significantly. But what about its usefulness? Californium-252 has the distinct capability of emitting a large number of neutrons, making it incredibly useful in a variety of fields, from initiating nuclear reactions to detecting gold and silver ores. All these factors contribute to its staggering price tag, up to $27 million per gram. So, while it's unlikely you'll find californium in your backyard, its unique properties and uses make it one of the most interesting elements on the periodic table.